All right, okay, so today we're gonna be looking at the Leetcode 257 binary tree paths. Hopefully you kind of know the problem. You can kind of read the description, go to the Leetcode and just read the description. So, okay, so there's multiple ways you can kind of solve this. The generic way is to obviously use depth first search, but today we're gonna do breadth first search. So if you kind of poke around the internet, breadth first search is just doing level order, right? Going level by level each node, and then processing nodes level by level. And you also find that people use queues. People will draw some queues and start adding item, right? One, and then and as the queue progresses with time, you process one, and then you add 2 and 3, right? And as process with time, you add the queue state will be like 5, like that, right? So you're adding node, you're processing a node, and then adding the left and right child of the node to in the queue, and then you do it across time. Now, I personally find this kind of it just takes a extra more brain cycle to visualize this, because you have this time dimension within queue. So it really is like a 2D queue. One axis you got time, and then one axis you got the queue itself. So it really you just have to visualize this a time dimension. And so I really don't like this approach of visualizing stuff. So the other approach I kind of really prefer when it comes to doing breadth first search and visualizing queues is as follows. So I just kind of like to overlay the queue on top of the tree. So that makes life easier for you. You don't have to do this. It's only for me. So the way to do this is you kind of go, let's make this longer. So, no, if that makes sense to you. So, yeah, I mean, this is literally just, you can imagine this is a squiggly queue. Queues can be squiggly in the form of drawing. So, yeah, I mean, you can really see if this was a queue, you can really visualize the queue right here and see that, one is the first one getting processed, and then after it processes one, you got 2, and then you got to process 3, and then process 5. So it really summarizes the whole, compresses the whole time dimension into a single picture, and really tells you what gets processed next. So in your head, in my head, when I'm trying to implement this breadth first search, is I really try to visualize this. Oh, okay, sure, the queue is gonna come over here, something like this. My drawing is bad, but you can imagine something like this, and then we're gonna have 1. So, all right. So with that said, right, after you have this visualization, the implementation is actually quite easy, right? Quite simple. All you gotta do is add. All you gotta be worried about is I just gotta add the nodes in the right order in this picture, right? So I gotta add 1 to the queue first, and then 2, and then 3, and then 5, and this just add stuff in the correct order. And if you do that right, your implementation should be right, right? So let's code it out a little. This is my first video, so I'm not quite sure what's the best approach, because you can find the code solution in the solution section. There's hundreds of coding answers, coding solution that you can find in Leetcode. But so let's just for this video, for the sake of this video, let's just assume that, you know, we understood we understood the idea behind breadth first search, right? And now we have to build a solution. All right, okay. Oh my god, this is really bad, but okay, cool. All right, so I mean, let's talk about implementation a little bit over here, I think, before jumping into the coding solution. So what we're gonna do is, like, we're gonna append one to the queue, in queue, right? And then, well, what we want is, firstly, we want paths, right, to the end. So we only append, so we probably need an array, some sort of an array, to have a path, to store some path, right? And when I'm visualizing, I've done this already, but so I know the answer, is like we need to, when we reach the leaf node, we need to, that's when we need to append paths. Well, in my implementation, you can implement it differently, but it's, what am I saying? Okay, cool. Yo, this is so bad. Hopefully, yeah, this video is just for me. I'm not hoping anyone to expect, take this video and kind of learn. So if you're learning from this video, I highly recommend you don't do it. It's not suitable. Okay, so right, so what I'm seeing is, like, okay, cool, I'm just gonna initialize my queue. I'm just gonna initialize my queue to have 1, and then just until the queue is empty, right? I'm just gonna pop out. I'm just gonna process the nodes in the queue. Yeah, I'm just gonna process the nodes in the queue one at a time. One at a time. So something like this. All right. So firstly, the base case, right? If root is what am I saying? If not root, then I need to kind of, well, there's nothing to kind of return. So let's just go return like that. All right. Okay. So let's initialize the queue to become, so let's initialize the root to become just root for now. All right, the first node. And while queue is empty, well, while queue contains something, right? While queue contains something that we need to process, what we do then is, well, okay, let's get the node out first. Queue dot pop 0. The first. Remember, we're it's a queue, so we gotta pop 0 out. All right, so let's process this node. All right, well, the question is, like, is this node, well, let's put the node left. Let's process the left node of it, right? If left, queue dot append, I don't know, like, say temp. All right, what do we want to append? Node dot left, but we also need to append the path. We also need to append the path of it, but okay, something like that, right? The skeleton of the problem is, this is the skeleton of the problem, right? Like, get the node dot right, and then queue dot append the temp, right? This is the skeleton of the problem. I'm not really thinking about, like, the extra path creation stuff right here. But what if, like, I guess, what if the node is, what if, like, they both are not, like, what if it is a leaf node? That's what I meant. If it is a leaf node, then we gotta check that, right? Not node left and not node right. Okay, if this is a leaf node, then we're gonna have some results over here, right? Then that's the path with res, or we can just say paths. Actually, res. Okay. So we gotta do like res.append or something like that, right? We gotta do res.append and put a path over here, right? But now that means, well, that means we need to have access to the path. That means, how are we gonna have access to the path? Well, we need to kind of somehow pass it, right? So maybe we can kind of like path like that. Okay, well, queued pop doesn't really, only returns node for now, so that means we need to make it such that when we do pop, we return the path. All right, so node, I think like that, root, and well, we need to create a path. So the path would be like, I don't know, like root.val, right? So we're building up the path as we go. So when we're 1, the path is just string value of 1. When we're 2, the path is 1 dash 2, right? And when we reach 5, the path is like whatever the path was, and you concatenate. Actually, yeah. So okay. Let's say let me say that again. So 1 creates 2 paths. When you're processing node 1 over here, you're creating 2 paths, like 1-2, 1-3. So meaning like, so an example would be like 1-2, and then 1-3. So when you're processing node 1, you'll be creating 2 paths. And when you're at the very leaf node, you have nothing to kind of create, so you have no child to consider, so you just append the path. All right, node.left, node.right, cool. Append, q.append. Okay, cool. Q.append. What do we do? Q.append. Right, temp. Right, this is kind of the basic skeleton of the problem, right? It's just having a queue, it's processing the nodes. And now what we do is right, okay, I think we're good. We also need to kind of pass like this, like, I mean, whatever we add to the queue really has to be a constant thing, right? We're adding a tuple of node and a particular path. So I'm in my intuition is like, okay, we got to do the same whenever we add something here to the queue. So the path will be like whatever the path currently is, right? Plus some like logic like that, and then node.left.val. Does that make sense? Yeah. Something like that. And then we can really just copy and paste it, and then just change left to right, right? And then really that's really it. And then return res. Let's see if that runs. Whoa, okay, something is okay, cool. Stir. Okay, cool. And over here we gotta do like that, and then stir. Okay, cool. Hopefully that runs. All right, okay, cool. That was the solution for binary tree paths. This is my first video, so I'm just kind of like I'll be posting more, so the iteration goes on, the videos will get better and better. But the first video, I'm expecting it to be quite shit, so take it for that. All right, cool. Cheers, thanks. I'll speak later. Bye.